Probably you got the permission, right?
Yes, I got the permission, sir.
Okay. Let us wait for 1 or 2 minutes and then let us start our discussion. Actually, I told you that there are 45 marks out of 300, that is 15% of marks. It is allocated for your assignments. Quizzes, actually, you don't take quizzes for the master's student, but you'll have to have a project presentation. So when will be the last span of examination? Nadeem, do you know it?
Sir, we haven't received any proper instruction about that yet, sir.
Why not? Because you are going with the first year student, right?
Yes, for first year students are at the last 10 days of this month, sir. So maybe from 22 or 23 October, sir, for the first year students.
For the first year student, 22 and 23 October, the exam will start, right?
Yes, yes, sir.
And it will go for continue for 2 weeks at least.
Yes, sir, probably.
Okay, so inshallah, I shall announce the date of your exam during this year. After the exam, you will have to present a project, or so you have to choose a paper, preferably from the IEEE transaction, from power electronics, industrial electronics, renewable energy, whatever power related, power electronics related, and just choose a paper, and if possible, discuss with me through WhatsApp. You can send the paper and tell me that whether it is okay or not, and then you go through the paper, try to understand. And those who will go for the review one, then they will have to make, say, 8 to 10 slides, and you have to present it before me, and I'll ask you question after your presentation, and then I'll give you the marks. Okay, let us fix the marks. Maybe 45 marks out of 45 assignments. We can keep it is around say 20 and 25 marks will be the project presentation. Okay. If you miss the project presentation, then 25 marks you will not get. Those who will submit both assignment, they will get 20 marks. Yes. Hello. I'm listening.
Sir, will it be individual or group presentation?
Yeah, of course, individual. Of course, this is the masters. This is not undergraduate, right? So you have to have this. What is that? You have to have this expertise to go with independently, right? Independently, you have to do that. You have to read the paper. You have to select a paper. It could be conference one, but the conference would be the IEEE conference, preferably not in our country, other than this country, maybe USA, Canada, or any other. Anyway, you can go for the conference paper also, but I prefer transaction paper. So those who wants to do the some simulation work from the paper, if they can, if you can just present your simulation and you can compare your simulation results with the paper one, definitely he will get 100% marks. But those who wants to go to the just review one, yeah, you can go, you can learn this thing from the paper and you have to present it, but you have to explain properly. Okay. So then now we shall fix a date, inshallah. The next class, next semester will start from the 15th of November, right?
Yes, sir.
Before that, we shall fix a date for the presentation. Maybe if you are around 22 students, say each one will be say 10 minutes. 7-minute presentation, 5 minutes question answer, 12 minutes. So maybe we shall sit one day from 9 to 1 o'clock, 4 hours. If somebody will left, then we shall continue after the lunch. We shall fix a date for the presentation. Okay. I shall post it to the WhatsApp group. Good that we will have an exam that will be similar to your midterm exam. The marks will be there will be 4 questions probably, right? 75 marks, 75%. Okay, I don't know what about your this time. Okay, so what we can do, we can make it like the undergraduate. What is the undergraduate things we are doing now? There is a marks division. There will be viva and there will be final exams. Okay, so we shall follow that one. So after the final exam, we can arrange a viva. Then from that viva, we can distribute the marks also. That viva question will be from here. The syllabus are after the midterm. Before the midterm, how much we have covered? I can remember that it is written in my note. From the NEDMO probably mark distribution. Okay, quiz and viva, that is your 30%. Midterm 25%, 25% detail, and 10% material. Altogether 100%. So then quiz and viva, that will be your okay. That is your 30%. It is not 15%. So 15% will be your for your say. We can make this one 30%. Like 30% is 90 marks. Quiz, viva, and also the project presentation. The 25% makes not 25%. There will be 4 questions you have to answer. Okay.
Yes, sir.
Okay. The final exam. We have then your midterm was 6.3.3.1, page number 164 up to that one we have covered, and after that we'll cover the final exam. That final exam will be the same way in the Google Classroom, inshallah. So I hope it will be inshallah in the month of November. Okay. We shall fix a date. Okay, let us fix a date. Today. Nadim?
Sir, actually, I was wrong about the exam of first year students. The exam will start from 25th of this month, sir, and will
Okay.
end at 5 of next month.
Okay, so okay, before the 5th November, we shall have the this exam. What could be the date, probable date?
I think we all can suggest some date.
Later, okay, in your WhatsApp group, make it maybe say, okay, maybe on 6th of November we can have the exam. 6th of November is the Saturday. Or 4th of November, 3rd. I think preferably 6th November. Is it okay? You just mind proposing rest of the things you select. Okay, then the last question will be from your inverter, inshallah. This inverter will be from your Harun Rashid. Most of the things that has already been covered in your undergraduate. So I believe that there should not be problem. And you can also go through the previous year's question, and you see what kind of questions are normally set in your final exam from the inverters. Okay, inverters. Let us start. Can I start?
Yes, sir, sure.
Yes, 21 students are present maximum. So this is the inverter, and you know that what is inverter, right? Inverter is the DC to AC converter. We have the DC and then we have the AC converter. Normally, what we do, we have that. Say, if you have AC, then we can use unregulated DC, and then we can make it DC to DC converter. So DC to DC converter, make it regulated, and then from here you use the inverter and get the AC. So AC is available, then why you are again converting it to AC? What is the answer? AC is available 220 volt, 50 hertz, and then even though then why you are making again AC to AC, then unregulated DC, and then make it DC to DC by regulated, and then use the inverter to get the AC. Why you are doing that? We have the already we have the AC supply available.
For driver, motor driver.
For motor driver, what is the difference? Can we not use
In this case, we can change the frequency of the.
right? You can change the frequency as well as change the voltage, right? You can have a variable voltage, variable frequency. So that is why we shall use this inverter. Okay. So I am just following the Harun Rashid's books. So inverters are widely used in the industry. Variable speed AC motor supply, renewable energy, transportation. Transportation thing is now electric vehicles. They are using the permanent magnet DC motor. Interior permanent magnet DC motor. There they use that from DC to they make that three-phase AC, and then they are using this one. In the induction heating, you can change the frequency and also you can change the heat. Standby power supplies, of course, like your UPS. Uninterrupted, yes. Standby power supply means that, okay, like IPS. The input may be a battery or fuel cell or solar cell or any other DC cell. Eventually, the input of the inverter will be a DC or AC. So conventionally, you can take that one from the solar cell, fuel cell, or any other source, right? The DC sources. The typical single volts are 120 volt, 60 hertz in North America, 220 to 50 hertz in our country in this region, and also UK. 150 volt, 400 hertz. I don't know where they use this one. For high power three-phase system, they typically 220 to 380 at 50 hertz, 120 to 208 at 60 hertz, 150 to 200 to 400 hertz. Inverter can be broadly classified two types. One is the single phase one, another three-phase one. But each type can use uncontrollable switch like turn on and control turn on and turn off, like your BJT, MOSFET, IGBT. Nowadays, actually, IGBTs are mainly used. This MCT, GTOs, these are not used. See, no. And also, if the input voltage remain constant, a current fed inverter or current source inverter, actually sometimes current source inverter or voltage remain constant. If the If the voltage is constant, we call it voltage source inverter. That means input voltage is always constant. And if the input current is constant, this is known as the current fed current inverter, or mostly it is known as current source inverter. These are the basic thing I am telling you because as master's student, I must know all these things. If the output current is maintained by a variable DC link inverter, if the input voltage is controlled, if the output voltage and current of the inverter is forced to pass through a zero, through zero by creating LC resonance cycle, this type of inverter also known as resonance pulse inverter. Chapter 7, next chapter they deal with this one. Those who will be working on, say, if you want to do some research work in the inverter, then you have to also read the chapter 7 and also from the net. Okay, like the what is that? Like your rectifiers, inverter will have some performance parameters. Let us see what are the performance parameters. Okay, so first equation 6.1. Can you see it? Hello? Okay. So this is the output power. Of course, this is AC, and that will be the output voltage, output current, and cosine theta, that is the power factor. And if it is resistive, then you can always find the RMS value and I scalar. Where V0 and I are the RMS load voltage of the load, and theta is the angle of the load impedance and R is the load resistance. The AC out input power will be known as the IS, because why it is there is no power factor here? Can anyone tell me? Input side, no power factor, because the input is DC, right?
Yes, sir.
You got my point? Okay. If the output contains some ripple, then the ripple content also, if the input is not sinusoidal, it contains some ripple, then the ripple current, the RMS of the ripple current will be governed by this equation number 6.3. That is I1 square minus IS square. What is II square? Where II and IS are the RMS of the average value of the DC. RMS means suppose you will have like this. Then you will have a DC supply. This is your IS. And if you have that RMS value of the input, you have to take the RMS value of the input, II. Then you can find out the ripple. RMS value of the ripple current like this. And also there will be ripple factor, that will be your IR, that is determined by the equation number 6.3, and IS is the RMS value of the this, right? I'm sorry, the power efficiency, like your rectifier, it has also the power efficiency, which is the ratio of the output power to the input power, and will depend on the switching losses, which in turn depends on the switching frequency of the inverter, because switching losses is proportional directly to the switching frequency. So if the switching frequency is high, then switching loss will be high, and if the switch loss is high, then your efficiency will go down. Okay, so look here. This is an example of your. This is a block diagram, IS and output next one, and output voltage we call it quasi or rectangular type. The output voltage is no sinusoidal rather than rectangular. If so, Then we will say that the IS current will have this one. It is just randomly they have taken. So then there will be average value. That is your IS, as we have already mentioned, and there will be RIP. We'll have to find out this, right? Then how can I, if we get this one, RS value of this one, and if we get this one, then I square. You use the formula. Okay. Total harmonic distortion. Harmonic factor is there. The harmonic factor is the nth harmonic, which is measure of individual harmonic combination. It's defined by. So for the n equal to, say you are trying to find out the third harmonic, then put n equal to 3. N equal to 3. Then b 3. Then just find out the RMS value of the third harmonics and also fundamental and divide it that the harmonic factor of the third harmonic. Total harmonic will be like this. So n is the number of harmonics. This is the distortion factor that is defined by this equation 6.71. DO, O stands for output, N stands for the number of harmonics. So you have to use this 6.7. And for the particular harmonics, you can use this formula 6.8. Okay, principal operation. Let us go to this one. Are you familiar with this one? Hello? Are you familiar with this type of figure? They call it half-base inverter. Are you familiar? Hello? কথা বলছেন না কেন? Why you are not? Can you listen to me?
Yes, sir.
Okay. So suppose you are turning on the switch Q1 for half cycle. Say this is half cycle. Then so kind of the using the equal magnitude of the capacity, you can define this BS by 2 BS. Then the kind will go the same. And this is off, and this is reverse, and the kind will come back. So you can find out the voltage G0 VAO. That means that this is VAO from here to here, VS by 2. And for the negative half cycle, when this one is off, then the voltage will go here, the current will go in the reverse way, and it will come back. And negative PS by 2. And if you now I1 will be the current. Which one? The current will be your Q1, that will be this one, PS by 2R. Suppose they forget this, yeah. And I2 will be this one, and that's the negative cycle. And these are the things I believe that you have already learned it in your undergraduate level. Okay, here, very interesting. If this is the inductive load, highly inductive, then the current will be 90 degree lagging, like here. 90 degree. So during this, when there will be no so this one is not working, but still there is a current. So D1 will be automatically turned on instead of this one. And then from here to here, Q1 will be turned on. And then when this will be turned off, and also the Q2 will not be turned on, then D2 will be turned on. And then when it is 0, you will have a what is that? You have a sense of when that it will have a 0, kind of 0, then you will give a switching signal, and then your Q2 will be off. Probably you forgot everything. These are the things we have already covered in this. And then the RMS value of the output voltage will be PS by 2. And also the instantaneous output voltage will be this one. By using the potential, this one. This will be 0. and then you have to find out IN and BN. Since it is symmetrical, P0 will be symmetrical, then there will be no second harmony. So then your A0, 0, AN also 0, then you have only you have the BN. And finally, you will get this to be the N. And then you substitute this BN in the equation, and then finally you will get the equation of the B0 by 6.10. And then now, because your first harmonic, third harmonics, these are all represented because it is symmetric in your t-axis. Then you put n equal to 2, 4, all these things at 0, and n equal to 1, 2, 3, 4, 5, then you will get this. For your fundamental component, you will get this one. Put n equal to 1, and then divided by root 2, and that will be this is the Rn value 2 ds by 5. This is your peak value, and RMS value will be 2 ds by root 2 5. This is your B0 1. When n equal to 1, this one is the B0 1. And then the current will be simply divided by the impedance with n. N there will be n because it is not sinusoidal. Then P01 and the power I0 is 6.13. I0 is this one. Is one you get this one. Yes. So, in your exam, not much different question will be set. Practice this one. This type of example. That will be helpful for you. You will set in the exam. Very easy using some of the formula. Now, full bridge inverter. Okay, it is not half bridge, it is full bridge. Now, similarly, you will get Vs by 2, and then VAO will be Vs by 2, positive half cycle and negative half cycle, like this. And VBO will be here negative. And when VAB you do that, then VAO plus VOD equal to VAO minus VBO. And if you negate this positive with this negative, and then you get this. And they have just found the fundamental component of the current. Theta 1 is the impedance. Similarly,
Sir, sir, here 0 is ground or O in the picture.
which one, please?
Sir, the 0 in the circuit, is it ground or is it a point?
No. It is just a flow reference point. They just like they are comparing this one with the half bridge inverter, right? From the half bridge inverter, this O has been connected here. It is just they want to make it okay. VAO, right? So the voltage between, just let me show you. VAO, this is positive, this is negative, okay? And VBO is the voltage between here. Then what will be your VAB? How can you find out VAB? Tell me. After the Kirchhoff voltage now. Negative positive VAO, then say positive negative VAB, then you are coming back minus VBO equal to 0. So VAB will be your VAO minus VBO. That will be. So now you have the VAO here, and here is the VBO here. If you negate, suppose this is 10 volt, suppose this is minus 10 volt, here it will be 20 volt. This one is just a reference point.
Okay,
Okay. Similarly, they have also mentioned here that when uh, the look at the current here, actually Q1 and Q2 will be on from here to here, but the current should flow here, then D1 and D2 will be automatically turned on here instead of Q1 and Q2. And here Q1 and Q2 will be turned on, and rest of the time D3 and D4, and then from here to Q3 and Q4, here again D3, D1 and D2. You check, very easy. Okay. So now, how the switches will be, there is a table. This table will give you how the switch will be turned on, state 1, state 2, state 3, state 4, state 5. Okay. So they mentioned that when the I0 is greater than 0, then S1 and S2 will be turned on, and D1 and D2 when I0 is greater than 0. S2, S3 will on, and S1, S2 off. All these things, whatever we have told here, how this switching will be done, they have tabulated in the table. So please go through it and try to find it. V01 will be the here. The same way we'll have to find out the equation. It is already here. So V0 will be this one, 4 pi n Vs. So they use this equation, and then they have found the V01, and then IS, the input current, and then this one, and then example 6.2. So then problem will be, you also practice this one. Your life will not be very tough in the exam. Okay? Now, we don't need the 6.3 because it is a little tougher. You don't need it, but you can have a look for the concept. Now the three-phase inverter. These are the main things actually, because before that, so far I have discussed, these are covered in the undergraduate level. Hey, my students, Nadim, Sanjita, did we cover all these things in our undergraduate level? Probably also three-phase inverter we have covered. Okay, so three-phase inverter can be obtained by connecting three single-phase inverter like this, and then you get the three A, B, C, and F. So this is not the practice. Actually, we don't do that. Look here, lot of switches are there. This is one single-phase inverter. This is another one. This is another one. Okay, and there's a person connected. Actually, so you are not telling anything, Nadim.
Yes, sir. I can hear you.
Can you remember that this 180-degree conduction and 120-degree conduction we have covered?
Sir,
in
undergrad, sir. Sir, I will be honest with you. I don't actually remember properly, sir.
Because you just
Sir, it was covered in the later portion of our lecture in undergrad.
Right,
so...
like 1 or 2 lecture I have covered, and I told
yes, sir.
You just practice this one or that one, right?
Yes, sir.
That is why you forgot, and most of the people you did not answer us. Okay, so 180-degree conduction. I am telling you. Look here. Here is the three bridge, and then we have to generate the switching frequency. This is your G1 is the gate pulse, and G2 will be your say G2. How can we level up this one? 1, this is 3 and 5. The same way the three-phase direct equipment. Then add 3. It will be 4, and then add 3. 6, and then this 2. Okay, this 2. This 6, this 4. This way you have to number that. And then how you will generate the pulses for the gate pulses? For G1, make it 120, make a 180-degree pulse. Look here, this is 180-degree pulse. And then stop for 180-degree, and then again do this. Then after 5/3, then for the G2, just give 5/3. That means 60 degree. Then 180-degree, 180. That is why it is 180. Then again after 2/3 is this. And this the rest of the things has been shown here. The rest of the things has been shown. And if you now apply this pulses to your this inverter circuit, you can find out the voltage VAB, VBC, and VCL like this. Okay. And then they have used this inverter for a delta or Y connected load, and with that one, what will be your current? All these things that has been shown. For this is your VAN, this is your VBN, this is your VCN. That is line to line, line to neutral voltage they have shown. Okay. From here you can find out. If you go through with this one, then you can find it from say from A to N. From here to here. Can you see my cursor from here to here? From A to S, A to N. What will be the voltage from here to here? That will be the voltage here. Okay, it will be 1/3, 2 VS/3.
কনভোকেশন এর ওই ছবিটা দিচ্ছি
Okay.
তো ইমেলটা তো জানতে পারছেন না
So this way you can find out, and there is another one. You go through this one. You try to find out the current. You don't need to solve the problem. Inshallah. Although in the undergraduate level, sometimes we said this 6.4, but here. Then there will be 120-degree conduction. Here now the pulse will be 120. Here the pulse will be 120. This one will be 120. And then you have to wait until another 120-degree, and then another. Okay. Here we start. And then after say 5/3. How much it is? Yes, 5/3, 60. If you do that, you can get the same type of results. So this is your 120-degree, and then similarly you can find out all the equations. So up to this, you have to be very careful. Maybe you will get 2/3 of question, and then there will be how you can generate the modern way to control the voltage in your inverter. There are some of the things. Sometimes I see what are the different methods, techniques of the PWM, so that you can get a sinusoidal output in your inverter. Then you have to write down this fact. Single phase, single pulse with modulation, multiple pulse with modulation, sinusoidal pulse with modulation, modified sinusoidal pulse with modulation, phase displacement. Okay, so there are some other advanced technique: trapezoidal modulation, staircase modulation, step modulation, harmonic injection modulation, delta modulation, and multiple pulse width modulation. How do you do that? Okay, here you have the carrier signal. If you do that, the triangular things are the carrier signals, and the switching pulse will be switching frequency will be depends on the frequency of this carrier signal, and then you have to compare, say AR, a constant, and minus AR. Then you will get these pulses, and you will have to apply this pulse. This is your G1, and this is your G4. So with that one, you will have the output voltage T0. Peak value is this one, this one, this one. After 5, you will get this is like, if you do the Fourier series, you will get this kind of thing. So this is the multiple pass with notation. And then next one is the sine per PWM. Sinusoidal PWM. So instead of giving the rectangular, then you will have that carrier, but in the both polarity, positive and negative. What I want to mean is that you will have positive, negative, negative. And then you will have this one and also have a negative of this. And then you have to compare these two things. And then pulses will be generated. This pulse G1 and G4. And then you will have to apply this, and then you will get this kind of output here. So this will be known as delta M. Sometimes the people call it delta modulation technique. Okay, you should have idea of all those things rather than you have to calculate these things in the exam. No, just to go through and try to understand. Modified pulse width modulation. Okay. So actually, people are doing a lot of researches to get how to get the sinusoidal pulse. Here it is almost say constant. So that is why they don't give anything here. They don't give any pulse. They reduce the switching loss. They only apply this one and they apply this one. This is the carrier signal, and they compare all to this one, and then you get the switching pulse. We are talking about this. This one, G1 and G4. And with that one, okay, figure out all those things. You don't need this figure, but you have to understand this one. This is the phase displacement. So you can change the phase of your switching. You have the idea, like this is your from your single phase. Can you know this one full relay? And then we got it, right? And with this one, then what do we do? We just shifted VB0 by an angle alpha. This is known as the phase displacement technique. And then you will get PS like this, sorry, DAB like this, the output voltage, and also get like this. This is very popular technique of the PWM technique. Then voltage control of the three-phase inverter. That is sinusoidal PWM. You don't need to go details at all. Just try to remember the. Look here. Is it possible to draw all these things in the exam? No. Just try to at least know the name for the three-phase modulation technique. Three-phase inverter. This is the 60-degree PWM you can apply. Third harmonic PWM you can apply. So those who will be doing some research on the inverter, they will have to go through all those things line by line, understand this one, and then you have to apply in your thesis work. The space vector modulation, actually in 2002, I have started doing something in my postdoc in Canada, but I returned home, so I could not finish it. But this nowadays is very popular technique. What is this? There will be some phasor. Here. With that phasor, then you can split the current, and with that one you can find out the switching technique, when and where you will apply this one. The theory, these are the theory it has given, and now it is shown how you will apply this pulses to regulate your switch. So that's try to know the name of this one, the space vector techniques. Actually, inverter should be this is the thing I'm trying to understand. So here, the vectorically you will have this voltage V1, V2, all are upper 60 degree, and then you have to move around, and then that should be a switching sequence somewhere given. Should be some switching trick. So those who will be working on this one in the I don't know, in future, if you want to do your PhD or master's in abroad, then you can use this one and propose a new technique and apply it, do the experiment and get the results and get 2 papers, and you will have your PhD. This is very important, but we don't have time. This is the things I wanted to. There is a table. How you will change this one? B00, 100, 110, 11. I have already done these things in Simulink model and try to apply this. And then at the time I came back home and I could have finished. If I could have finished, then I could have some IEEE transaction papers. There is another technique known as harmonic reduction technique. So here, particular harmonics will be eliminated. There will be 2 types of harmonics reduction technique. One is known as the unipolar, and another is known as the bipolar. This is unipolar. Now, that's it. What will be the question then? What is inverter? What are the different types of inverter? What are the applications of the inverter? Then what is the say 120 degree conduction of the 3 inverter? What are 180 degree? We have to explain all this thing, but you don't need to. And then there is the full bridge inverter, half bridge inverter. We have shown there. Maybe one was full bridge inverter probably, and there is an example 6.2. And what are the different type of texts? You just try to learn the name. And the current source inverter. Current source inverter, there are very many inductors in the and then the breeze is here. And then look here, there is no, very important thing is that there is no freehold in that here, no name. I know that you are not very much happy with today's class because lot of things are here. Actually, inverter things should be a course to learn. Okay, so but we will have time. That's it. If you have any question or anything regarding the exam, so please ask me. So where we have finished? When we have finished single phase rectifier with LS. Am I correct or not? So
Yes, sir.
after that we have learned what? 3-phase rectifier, diode rectifier without LS, 3-phase diode rectifier with LS, 3-phase control rectifier without LS, 3-phase control rectifier with LS. That we have learned. And then this is the part of the probability, right? Am I correct or not?
Yes, sir. DC-DC converter also.
Oh, okay. So this is DC converter. Okay. Now, then how actually what should be the question then? One question will be from your say diode rectifier with LS, without LS, 3-phase, of course 3-phase. And another question will be the control rectifier with LS, another level. Another question will be the DC-DC converter. I think 1.5 and half question will be from inverter. What do you think?
Yes, sir.
I think that will be better because inverter things we did not cover much. So you have to answer any three. One question will be your three-phase rectifier. Today write down. Today write down or you want to today write down here. Hello.
Yes,
Yes,
sir,
sir.
that would be better.
One question. Diode three-phase. Three-phase diode rectifier without plus three-phase rectifier plus DC-DC converter. 4. Half DC-DC converter and half DC-DC. How is this? How will be this?
Okay, sir.
I think that would be better, right?
Yes, sir. Yes, sir. So total marks is how much? 75?
25%. That means 75 out of 300. Out of 300, 75 marks will be your year. Okay, let us distribute the marks. Midterm 75. Midterm 75 final, right? 75 project plus oh. $75 project plus assignment, right? Assignment. And then 10%. 10% means what? 30 marks, 5 marks. And then how much left? How much left? 45, right?
45.
Okay. So then for 45% will be your 5 mark. 45, not 45. 45 marks will be 5 mark. 30 marks will be your attendance. Okay? Is it okay?
Yes, sir.
So don't worry. Those who will be present in the exam, sorry, Viva, 25 marks, starting marks will be 25. You got my point?
Thank you, sir.
Yes, sir. Thank you, sir.
And then I will ask some basic question. You have to answer those and then you will have to add the marks from this one. This will lessen your load in your final exam, okay? Written exam. So, okay, then you fixed your theoretical exam, fix date of theory, fix date of Viva, and fix date of project. Is it okay? Consult among yourself and give me the date. Sanjida, are you here? Sanjida, তো দেখলাম তুমি চলে গেছো না কেন?
হ্যালো স্যার, সরি আমার নেটের একটু প্রবলেম হচ্ছিল।
আচ্ছা ঠিক আছে, সমস্যা নেই। তাহলে আমরা তিনটা জিনিস ফিক্স করব, আমাকে জানাবা তোমরা। একটা হচ্ছে এখন অফ করে দাও রেকর্ড।
আচ্ছা স্যার।